Hey, this is Lester Martin from Hortonworks University, and we're continuing on in our Hadoop Essentials course. This next module is focused on Apache Pig. Quick lessons. This will be a very quick lesson focused on Pig, and then we'll jump into a demo. And again, we'll just try to make sure you understand the backdrop, why we have Pig, roughly how it works, how we interact with it, how we execute it, maybe see some existing operations commands that are pretty much the stable that most Pig programmers are using from, and then as well as some additional libraries for analysis and those things that may be published out there in open source that you can take advantage of. And then we'll wrap up just with some awareness of how Pig and Hive can interact through hcatalog, as it says there, to leverage schemas, attribute types, etc. And finally, a quick Pig demo on the trucking data that we've been building in this course. So Pig's icon is a pig. As you see, I'm sitting on top of Hadoop right there, Hadoop. And, you know, Pig has a little bit of a mantra that you hear people talk about, the Pig team, and it goes something like, you know, pigs eat anything. That we're suggesting that pigs can process, you know, structured, unstructured data, any kind of data. Pig is glad to consume and eat. Pigs live anywhere. This one, while we're talking about Hadoop here, the suggestion was that Pig itself is a parallel data processing framework that could run on many places. And its focus and heavy use is on Hadoop, but one could argue even the simple local mode allows you to do something like that. Pigs are domestic animals. Definitely I would stand by that one, just like the pigs eat anything. Easy to control and modified by your users is kind of the phrase there. And then lastly, pigs fly. The intention is we're processing data very quickly. You know, some people are going to decide what very quickly means, and you know, Pig actually now can leverage, in addition to MapReduce, can leverage TES, which does actually increase some speed lift like we had talked about in Hive as well. So again, we think of Pig as kind of a scripting language of executing programs. It has a language that we call Pig Latin. And it can be visualized, and I'll show you an example here in a second. It can be visualized as a data flow, a scripting language where we make an operation, and then we make another operation. We read something, then we maybe filter that, or then we project it to get rid of some unknown columns that we don't care about. We read another file, we join those, we sort those kinds of things that you think about in data flows and data pipelining concepts. Very straightforward. And what you'll see when you build this is the reality is Pig is going to wait until it sees some kind of I/O event like a dump, which just displays the contents that you're asking for on screen, or store, which physically says, hey, let me write this back off to HDFS, I'm ready to go. So it's going to wait and kind of build this logical plan until it sees that I/O event, and then says, oh, great, I need to execute. And it's doing that because as you walk through, you may or may not be thinking in the most logical way, but when it gets all done up through, it can backtrack and see what you want to do and ultimately identify the least amount of steps that we want to do. So here's an example on screen, and we'll do a demo briefly in a few minutes here about that. It's not this exact demo, but this kind of theme you'll see referenced there. So example, read a couple data sets. I kind of mentioned this, maybe sort them, or filter in this case. Filter and sort, yep, join, maybe get a certain number of those things. So again, I'm not going to dissect these commands since we will walk through a demo and we'll go command by command and just kind of talk through them. But if you take a moment and glance at them, they are pretty straightforward, right? Load a file. That's that first big command. Line 4, filter. You know, hey, from those things we loaded, let's only focus on a particular age. Then maybe we read another file, maybe some web logs, it looks like. And then we're going to join those two values by the user. Group. We then do regenerate where we by that grouping, by that URL, we're looking for a count. We're ordering by the count number, then ultimately we're looking for the top 5 sites. So that's something that's very straightforward from a logical definition. Hey, I need to look at this input file, and you do this step, I need to do this step, and do this step. And Pig lets you program in that very logical, simple, straightforward model. And then when it hits that step, like at the very bottom in that last line where we say store, it actually really takes a hard look at the logical plan and ultimately builds some kind of physical plan, makes some decisions about how this is going to be run, and then executes that for you. You have a couple opportunities in Pig. One is an interactive shell. So some of the languages have this concept of an interactive shell where you can command by command, and this is a very good kind of prototyping place. Try things out, or even if you're putting your data analysis hat on, your data science hat on, you're just trying a variety of different things. You haven't really thought about this long-running program that has pre-identified all the steps. You may, from that activity, has lots of good command history. From that activity, you may ultimately build something together that says, hey, great, I want to package that set of steps up and run them as a standalone script. So the grunt shell's good. Once you get them ready to run more of as a start to finish kind of a model, we call that usually a Pig script instead of working through the Pig shell. Again, this is what you saw just a couple slides ago. Here's another example. Some batting data that we're playing with there. Very good stuff. In fact, this is one of our tutorials that I was responding to the HCC site, the Q&A site that we host, where someone was asking, could I do it this way instead of that way? So I was implementing that and showing them for it. But this is preferred model here, the tool that of choice. You got lots of color coding, you got lots of helper builders. As you can see kind of right here, this Pig helper pull down. And I'll show you that in a demo, how that will help you, if you don't really know the syntax perfectly well, help you kind of pre-populate some of that syntax. As you're building, a Pig script, or you're interactively working through the shell, this is a pretty good, pretty indicative list of the commands you have available to you. Simple and novel commands: loading, writing, looping, trimming, joining, ordering, flattening, the distinct and other concepts. So this is not a definitive list by any means, but it is indicative of the kinds of things you're going to do. And Pig's done a really good job. It's been out there for a period of time. A really good job of having a really good documentation on pig.apache.org. And if I didn't say it, I'll go ahead and say it now. Pig surfaced about the time that Hive surfaced. It surfaced with the same real requirement. Folks were looking at writing Java MapReduce, and the barrier to entry was kind of high for a lot of folks. And obviously SQL, you can understand where that came from, but maybe some of the people that were really doing a lot of work in Hadoop in those times too were kind of that Linux, Unix system administrator type person. And they already thought about this concept of command, pipe that into this, grep this, clean that. So they already have this concept of this kind of scripting, pipelining information. So Pig surfaced really for the benefit of that audience. Definitely not your hardcore Java folks. They were happy writing MapReduce, but it benefited for someone that said, hey, I know what I want to do. I know these steps, and I want someone else to take care of the fact that this is a parallel an opportunity to run in parallel at a large scale. So again, here's some good straightforward examples. And during the few years, of course, as people come develop more and more functions, etc. Pig, also like Hive, and I probably didn't talk about it, Hive and Pig have a concept called user-defined functions, UDFs. And they both have built different collections of libraries. There are plenty of them available out there on the internet. You can build your own. And then for Pig's perspective, one of the larger ones that's been kind of pre-compiled, and it's an Apache project as well, is called DataFoo. Again, primarily focused around data analysis, data scientists type audiences. As you kind of see listed there, some of the core functions that DataFoo surfaces and deals with. And then lastly, I want to make sure you probably didn't see it from the little scripts here, and you really probably won't feel the pain from this when you see the demo a little bit. But in Pig, the reality is you have to kind of define your schema, because pigs can eat anything. You can point it at any kind of file, and you have to kind of apply how you want to declare things. Now, Pig will do its best. It'll do a zero-based numbering system. It'll have a generic data type that collects everything. But if you really know that field 1 is a first name and field 2 is the last name, field 3 is their zip code, those type things, you'll have to build that schema when you do a load. Load that file and using, or as, and you'll define a schema. Now, if you already have something declared in Hive, so if Hive is already pointing to some data that sits on disk, yes, Pig can just read that file, but Pig could also interact through a library called hcatalog. So the hcat loader, the hcat store, or the classes in very particular, and you can then take the benefit of the fact that there's already a schema around that data. There's already definitions around how many attributes, what are the names of the attributes, and what are the attribute types. Those kind of basic foundational things can surface, and this gets a whole lot easier. So this is not just reading, it's also writing. At the end of a Pig script, many scenarios where Pig might be that ETL, the transformation element of your workflows, where we do a lot of lifting, changing, enhancing, modifying, etc. And then ultimately we might insert that data back into, or in Pig's case we use the command store, into, and we'll just reference a table name, and we'll say we're using hcatalog to help us locate and find that table name. So it is some really nice integrations between Hive and Pig through this concept called hcatalog, which exposes the metastore information. So as promised, it was a quick session here on Pig. I'll just ask a couple of questions as has been the normal. Maybe number one, what's the name of the programming language that Pig uses? And interestingly enough, it's called Pig Latin. Kind of a little fun with that one. And maybe a couple ways we could execute Pig. If you remember, there's an interactive shell called the grunt shell. Or you can just build a script, and that could be just a text file that has your Pig statements back to back to back, and then just invoke the Pig executable, reference that Pig script name, file name, and then you're off and running, start to finish. And then I kind of talked about this logical plan that's building up as you're going along, as you're defining these operations. Do this, flip it that way, add this, filter that. Really, Pig's looking for these, I/O, kind of looking for that notion of time to store something. It's really looking for that write to the screen, write it to disk, that it actually then finalizes what he thinks he should do, builds a really solid physical plan, and then executes upon that, and starts running the job or jobs under the covers. That'll be MapReduce or TES, to implement what you're asking for in that script. And a popular data analysis library is DataFoo. That's definitely one that has a lot of utilization and a pretty good following out there. And then lastly, we just talked about that. It's hcatalog that allows us from Pig to pick up the schema definitions previously created via Hive. In fact, if you were only doing Pig processing and you had no need for Hive, I would still recommend you declare tables around fields, data sets, that benefit from somewhat of a structured value to them. What data name, column names are, attribute names are, what data types are, etc. And by doing that, just by declaring some create tables, you give Pig a really easy chance to retrieve and store that information. And then the side effect is you really reduce the barrier to entry for your organization to now investigate Hive as well and say, hey, is there value in utilizing that SQL interface on the data that we have out there? And then, as we have always done after the knowledge checks, a quick summary almost mirrors the knowledge check that I just walked you through, let you glance at that. And then we'll finish up with a demonstration focusing on the truck data and trying to find risky drivers and good drivers and things of the like.